Hello everyone, my name is Champat Garg. I am studying MTech from Thapar University. Today I am going to present you about my research work, and this is the title of my research work. So before going discussing my project work, let me familiar you with some basic terms used in my work. First of all, what is ant colony optimization? It is a probabilistic technique for solving computational problems. Means based on the probability we will choose those paths only which give us optimal solution. Ant colony optimization inspired from natural ants. Just like natural ants keep wander randomly searching for food, and after getting food and returning to their nest they keep depositing a chemical named pheromone on the path, and with the help of those chemical, upcoming ants start following that path, and this process keeps going, and finally ants get a short path for their food. And this is the important thing to note, that shorter the path means higher the pheromone concentration on that path, and higher the pheromone concentration means higher the probability of the path followed by the ants. As you can see in the diagram, there are three paths P1, P2, P3 between ant nest and food source, and these dot represent the pheromone deposited by the ants. In second diagram you can see that path P2 has higher pheromone concentration because it is the shortest path, due to which more ants are following that path, and P3 is the longest path, due to which it has lower pheromone concentration and fewer ants are following that path. And at last all ants start following the shortest path, path P2. Regression testing. It is testing the software when any modification is done on it. Sometimes this modification can affect the components of the software which are already tested. To test them again, regression testing is performed by rerunning all the test cases. In regression testing, we need to run all the test cases again for the software maintenance, which is very time consuming and led to high cost. So our objective is to minimize the execution time of the regression testing by selecting only few test cases such that they can cover all the faults. For example, we have total 10 test cases and total 15 faults. Each test case has a execution time, and each test case can cover some faults. This asterisk is marked against those faults which can be covered by the test case. Now our aim is to select a subset of the test cases from this set such that that subset can cover all the 15 faults. Suppose we have 6 test cases. First, ant will select randomly any test case, let's say T1. Then it will check whether the test case T1 can cover all the faults or no. If no, then it will move and will choose the next test case.